So it might take you a little longer to get through the problems, but there's nothing in here I don't think you guys are in, that I think that you guys would be incapable of. You're a pretty smart group, so I think you guys will get all of this. It can just be tedious. So we're moving on with polynomials. We started on polynomials earlier this week, and we went on a little tangent into the rules of exponents, right? So your homework will be in Delta Math, and the first part will be on the rules of exponents. And then the second part will be on polynomials, and it'll be very specifically adding, subtracting, and multiplying polynomials. Next week, we'll start worrying about dividing them, because there's a lot that goes into division with polynomials that, is just a little bit more tricky, and I didn't think I could get it all into one lesson. So first thing you should know is, what are polynomials? They are the sum and or difference. Sum is really, and difference are basically the same thing. The sum or difference of multiple nomials. That means we are taking parts of multiple nomials. Now, what is a nomial? We went over that last time. Like 3 could be a nomial. X squared is a nomial. 4x to the 5th is a nomial, right? Negative 2x to the 3rd is a nomial, right? They're like groups of things that are connected. And when we're talking about polynomials, we're just adding multiple ones of them, right? They are always, well, let's start with this. The highest degree, or the highest exponent is called the degree of that polynomial. It's called the degree of the polynomial. So if I have an exponent, if I have a polynomial that's like 2x squared plus 7x to the 5th plus 2x minus 4x to the 7th plus 2, right? The degree of this polynomial would be 7. Third, you'll see me breaking a rule having in this one, because it says that the standard form is always written in descending order. Does anyone know what descending means? Descending means highest, yes, large to small. Your highest degree to your smallest degree. So if I were to take this same problem that I had up here and I were to write it in descending order, I would have to start with minus 4x to the 7th plus 7x to the 5th. And then we go to plus 2x squared plus 2x minus 2, right? That would be written in standard form, highest to lowest degree. And that's how we classify our polynomials. We classify them by the degree that we have. If I have just a number, like 1, 4, -32, any just standalone number, it's got no variable, we consider that to be a constant. And we kind of call it to the 0 degree, but it's really not to the power of 0 because otherwise it would just equal 1, right? Remember, anything raised to the power of 0 equals 1. Then we would have things like 2x or 3x plus 1 and things like that, right? Where there's no power written. So we're talking about that degree of 1, right? Where we don't actually write the power. And those are considered linear. When we graph a constant, it's just a point. It would be just a point on a number line. When we graph something linear, it's like a straight line that's graphed on, say we had like an XY axis, right? Linear is always going to be some kind of a straight line, right, on that graph, right? Could go in either direction. It could be like completely straight across, but linear means a straight line. That's why we call it that. And anything without a written power that has a variable is going to be linear. Where a constant would just be a point on a number line. Next, we would have things like 3x squared minus 2x plus 4, right? We call that a trinomial, but what trinomials are, which you might remember from last unit, were what we called quadratics. And quadratics always have the same shape. When we graph them, they always make a U. Could be like that. Could be upside down. Heck, if it was on the y-axis, it could be like that or like that. But those are always called quadratics, right? They always have that U shape to them. The next one I will get into is, say we have like 4x cubed or even just x cubed, right? Anything to the third power where your highest degree is the third power, we call that a cubic. And it graphs something like that, right? Where they go off in the same direction, in opposite directions forever and ever. Sometimes it'll look like this if it's negative, but same thing, right? One's going to positive infinity, the other's going to negative infinity. And we could go into further ones like quartic and quintic, but honestly, I didn't even ever know the names of those. You know, after this, we always just say polynomial. But one of the things to know about this is if I have an odd number as my highest degree, you're usually going to see a graph that looks like this. If you have an even number for your highest degree, you're usually going to always have that U shape, right? So you can kind of tell just by looking at them what kind of a degree you're going to have, right? Anything bigger than that gets crazy. And we will be talking about things like that and how to reduce them somewhat so they're manageable. But you don't have to like memorize any of that. Those are just kind of things to know that help you in terms of being able to deal with them. All we're doing today, as far as practice goes, is we're going to add, subtract, and multiply polynomials, right? And I think the best way to do that is to just show you examples, right? So when we're adding and subtracting, we're really just combining like terms, right? Combining. And writing them in standard form. Right? So we're going to look at some problems. I'm going to show you how they work. Addition, super straightforward. Subtraction, you got to be a bit careful with. So if I have an example, say 3x squared plus 11x plus 4, that's a 4, plus, and what makes it addition is this plus in between the parentheses, right? Anything else can be negative. What makes it addition is the plus between the parentheses. Minus 5x plus x squared minus 13, right? Technically, when I have a problem like this and it's addition, the parentheses don't even matter. I could erase them if I wanted to. They don't matter whatsoever. We can just combine our like terms, do it in the proper order, and they'll all be lined up in standard form for you, right? But when we have subtraction, it gets a little more complex. So I look at this and I go, well, what's the highest power of any of these, right? And for us, that's the square, right? The square is the biggest power we have in anywhere in here. So I'm going to start with 3x squared. And I'm going to say, is there any other x squared? So here I have 3x squared, and here I have x squared. So I'm going to add those together. I'm going to go 3x squared plus x squared. And I'm going to get 4x squared, right? I just added those two like terms together. And then I'm going to move on to the next highest degree. And for us, that is going to be 11x. So I'm going to go, okay, well, I've got another x over here. So I'm going to say 11x minus 5x. Well, that is plus 6x. So our next thing is just the constant, right? We don't have any more x terms. We've used them all up. So I'm going to go 4 minus 13, which is going to give me negative 9. That is all we have to do when it comes to addition, right? Nothing complex. We're just adding the terms that are alike. When we subtract, though, things become a little bit more complicated, right? If I have, for example, 5k to the third power minus 2k squared plus 2k minus 2k, oops, I need another minus there, minus 2k squared plus 2k plus 17. Now, if I want to, I can pull everything out of this first parentheses and just play it like it is, right? I could rewrite that as 5k cubed minus 2k squared plus 2k makes no difference. But this negative changes everything here when I try and pull it out of the parentheses. Because we're not just saying, if I were to erase the parentheses on this problem, right, like I would with an addition problem, it looks like the only thing that's negative is that 2k squared. But we're not saying minus 2k squared. We're saying minus this, this, and this. So we have to apply that negative to each piece. We have to distribute it to each piece in there, which ultimately just changes the signs of everything in there. So when I pull this out, this would become minus 2k squared minus 2k minus 17. And what that does now is once we've pulled it all out, Then we can combine those like terms, and we don't have to worry about signs anymore. Everything's the sign it's supposed to be, and we can do the same thing where we're going to reduce it. We're going to look at our highest power. Well, that's 5k to the third. Nothing else has a third power. So we are just going to leave that 5k to the third power alone. And we're going to go ahead and move on to anything that's written to the second power. So I have minus 2k squared minus another 2k squared, right? I can combine those, and I get minus 4k squared. So we've taken care of anything that's to the second power. Now we're going to move on to just k. Well, I have 2k minus 2k. That makes 0. So I'm not going to write anything for it, right? I get to move on. They just canceled each other out. So I'm going to move on to just what my number is, my constant. I only have one constant. It's negative 17. And I can go ahead and put a box around that because I am done. Does that make some sense? This is the one that you're most likely to mess up on because you will forget to distribute that negative to each piece. So I need confirmation from all of you. Do you see that? Do you get it? I got faith in 3 of you so far. 4. Going for the whole 7. Lana, do you get it? Sam? Who am I missing? Sam gets it. Grace gets it. I'm just missing Alana. I'm going to assume Alana doesn't get it. Well, I'm going to go ahead and move on to multiplication. Remember, I said multiplication is the last thing that I'm going to do today. We're going to save division for another time, which will be the next time I see you. When we multiply polynomials, a lot of you have done it. You might recognize the term FOIL, which back in Algebra 1 you might have heard of as like first, outer, inner, last. I don't like the term FOIL myself. And the reason for that is it only applies when we're multiplying binomials, when I have something like 3x squared plus 2 times x plus 4. This would be a binomial, and foiling works for that, but it doesn't work for any other type of polynomial multiplication. And so the way I like to teach it is that we are going to take the first piece right here, and we're going to multiply it times this, and then we're going to multiply it times that, right, to every piece in the other parentheses. And once we finish, we're going to take the second number, whatever comes next, and we're going to multiply it to each piece. So what does that look like in reality, one at a time? Well, I will show you. And this is where I'll probably give you the most examples, is in multiplication, because it's probably the little bit more complex part. So I'm going to start with this 3x squared. And I'm going to go 3x squared times whatever the first piece is. So 3x squared times x equals 3x cubed, right? Because we add those exponents. Then I'm going to multiply 3x squared times 4, and I'm going to wind up with plus 12x squared. I've played out this 3x squared. It has been multiplied by everything in that second set of parentheses. So I'm going to move on to the 2 now, and I'm going to go 2 times x. Well, that equals plus 2x. Then I'm going to go 2 times 4. Well, that is plus 8. Now, the only thing we would have left to do would be to write this in standard form, but the way ours happened to play out, we are already in standard form, right? We have 3x cubed, squared, x, constant. It's already in the standard form. It's already in descending order. And so this would be our final answer on this problem, right? But it isn't our final problem because I know how excited you all are about this. And so you want to see multiple types of multiplication problems. And so we're going to throw down here with a couple more examples, right? First one I'm going to give you is, we're going to say W minus 7 times W squared plus 2W plus 1. Now notice, this is a binomial, but this one here is a trinomial. It's going to work the same way, though. I am going to take this first number, this W, and I'm going to multiply it by each one of these pieces. Right? I'm going to go W times 2 gives me W cubed, right? W times W squared gives me W cubed. And then I'm going to go W times 2W. Well, that gives me plus 2W squared. And then I'm going to go W times 1. Well, anything times 1 is just itself, so we get plus W. And that W's been played out now, right? We've multiplied it times every piece. And so now we're going to take the negative 7, and we're going to go negative 7 times W squared. We're going to get minus 7W squared. And then we're going to multiply it times 2W, and we're going to get minus 14W. And last but not least, we're going to multiply it times 1. And we're going to get negative 7. Now, the last thing that we have to do is combine our like terms in descending order. So I'm going to look for the highest power. In that case, our highest power is that W to the third. Nothing else here has a third power. So it stands alone. We're just going to leave it alone. We're going to go W to the third power. And then we're going to go to anything that has a second power. So I have 2W squared minus 7W squared. So 2W squared minus 7W squared is negative 5W squared. So we've played out all our squares, and now we're going to go to anything that just has a plain old W. And I've got W minus 14W, right, which is going to give me negative 13W. Last but not least, we have our constant. There's only one of them. It is minus 7. And notice, because I combined my like terms from highest power to lowest power, we're already in standard form. So we don't have to redo it to put it in standard form. That's why I always go highest to lowest when I'm combining my like terms, because it saves me a step. And it helps us keep together in our head what we've done and what we haven't done. Does that make sense? Do you guys get that? Kinda. Well, I'm going to give you one more. I'm going to make it a little bit more complex. It's going to have a little subtraction in it as well as multiplication. It's going to be a little crazy. We're going to get crazy on you. But hopefully that'll help clarify for anyone who's kind of struggling with it a little bit. So, new example. Why am I in like tiny percent? Now I'm big percent. Now you guys will totally get it because it's way big. So if I have 2x plus 1 times 4 minus 9x minus 2x times 3x plus 11. This looks like a lot, but handle it piece by piece. First, we'll multiply these two, and then we'll deal with this mess. All right? So I'm going to start just like that. I'm going to take my 2x, and I'm going to multiply it times 4. And that's going to give me 8x. Then I'm going to take 2x, and I'm going to multiply it times negative 9x. And that's going to give me negative 18x squared. 2x has been played out. It can't be multiplied times anything else right now. So we're going to take 1 and we're going to multiply it times 4. We get plus 4. Then we're going to take 1 and multiply it times negative 9x, and we're going to get negative 9x. Now I've got this minus 2x times 3x. I'm just going to multiply this through each piece. Negative 2x times 3x is negative 6x squared. Negative 2x times 11 is negative 22x. Now all we have to do is figure out what our highest power is. And in this case, the highest degree that we have on any of those is 2, right? We have this squared here and this squared here. We don't have anything to the third power. And so we're just going to combine our second powers. We're going to go minus 18x minus 18x squared minus 6x is minus 24x squared. So those are done, right? We covered the x squareds. Now we're going to do our x's. We have 8x minus 22x. Well, 8x minus 22x, that is definitely going to be negative, what is that, 14x. Oh, whoa. I missed one though, right? Because then I got this 9x, right? I forgot that there was a 9x too. I went all the way from here to here. But now I still have this minus 9x. I'm just going to rewrite it, and we'll get back to it. And we'll go plus 4, which is our last bit. So because I missed that 9x, I have to go ahead and subtract that 9x. And I'm going to wind up with 24x squared. Now I have minus 14x minus 9x. Well, what happens with that is I wind up with minus 23x plus 4. Is that our final answer? Yes, it is. Right? We didn't miss any pieces. Everything's been combined. And it wasn't that hard, right? We just had to take it in bits, right? We handled this piece first and found out what we had, and then we brought in this piece. Does that make some sense? Okay. Your homework, should you choose to accept it, and I hope that you will,